Yeah, g'day, ZL2CTM. Just thought I'd do a follow-up video from last night based on some feedback from Simon Michael on calibrating the Si5351. And just listening there to an 80-meter signal.
Where the house is going to go. So there it is.
So that's considerably better than it was yesterday, which is great. So that was just basically calibrating the Si5351 and then removing, as a result of calibrating that, the fiddle factor. And as Simon quite rightly points out, that fiddle factor wouldn't have been linear across the 40 and 80 meter band. So what I'll do now, I'm just going to pause. Like I say, that's really nice and clear, which is great. So I'm going to pause here and I'll set this up for the calibration and just very quickly run you through what I did, and hopefully that will be of use to someone else who's looking to use the Si5351. Okay, so I'm set up here and I'll run through the hardware setup in a sec. Now, I run an Arduino library from Jason Milldrum. And when you install Jason's Si5351 library, that I've been using for quite some time, into the integrated development environment for the Arduino, when you then go to File Examples, and you go down, you find his library, which for me is down here. One of the options he gives you, one of the sketches he provides for you, is this one called here, the Si5351 Calibration. So this is what we're going to use to find out what the calibration figure needs to be for that Si5351 in order for it to output exactly the right frequency for the particular crystal that it has installed. So we're going to offset that crystal inaccuracy. So once you've started up this Si5351 calibration program, you then upload it into the Arduino. Once it's been uploaded, go to Tools, Serial Monitor, and you'll get this little user interface pop up. Now, you'll see up there the user interface gives you some options to press some various keys that correspond to the keyboard. So to make sure you just clicked up in here into the send box. And by using, for example, the U, that would increment by, it says here, 10, and J would decrement, so down. 0 there, or O I should say, not 0. O, increment by 1000, and L would decrement by 1000. As it turns out, for whatever reason, my keys aren't mapped exactly to this. So when I push a K, I actually increment by 10,000. So that's just, I'm not quite sure what's going on there. It doesn't really matter as long as at the end of the day we get the right number coming out. So in terms of the hardware setup, so that particular calibration program talks about monitoring the output of clock 0 of the Si5351, which is over here obviously. It says in the instructions to feed the output of clock 0 into a frequency counter capable of counting down to 1 Hertz or better. Now, I don't have a frequency counter that can do that in the shack, so I'm going to use a different method. I'm going to use my oscilloscope set up in the XY mode. So for that, I need 2 inputs. So I'm in the XY mode here. I need the 2 inputs, and input 1 is going to be, it doesn't really matter which one, but in this particular case, input 1 is going to scope the output of clock 0. So clock 0 here comes across this black wire and actually goes into this mixer. So I'm tapping off that, and I've just got the scope sitting on 10 times just to reduce the loading on that. Input number 2 on the scope, that's coming through, and that's going to monitor the output of my SIGGEN. Now, and again, I've got that set for 10 times, and I've sent the amplitude of the output of the SIGGEN to give me, when you're in the XY mode, a relatively sort of nice square there. Now, that software is going to command the Si5351 to output 10 megahertz. So I also need to then set my output of the SIGGEN to 10 megahertz right across, so 10 megs exactly. And what we're going to do, we're going to adjust, or that calibration software, what it does, it sends to the Si5351 a calibration, a calibration number, which is then used internally within the phase lock loop to determine what the output frequency is going to be. I won't go into that. Simon Michael, who provided the input of that, he's done a very good write-up in the comments from the previous video. If you look through that, he explains it in a really well, actually, why that's important, as opposed to what I had been doing, which was to use the fiddle factor. But anyway, so by pushing those keys on the computer, it's going to send down into the Arduino that correction code. So again, that correction or that calibration number, that then is going to be sent through to the Si5351. And if all goes well, once we get it exactly right, we should get a nice circle there. Not a figure of 8 or any other kind of shape, we're after approximate circle there. And that tells us that the two frequencies that they're in, same frequency and in phase. So that's what we're after. I'm not necessarily after the phase, I'm certainly after the frequency. So what I'm going to do now, I'll leave the camera sitting looking as much as I can at the SIGGEN, so again the oscilloscope, and I will adjust using that user interface, that calibration number. So I know K, pushing K is going to increment for me, for whatever reason, by 10,000. So 10,000, now 20,000, 30,000. I've gone a bit too far there, so we'll come back. So I push that one, and then you can that. So right now up to 34,000. We'll keep adding in some more. And we're starting to get close now. We're getting closer and closer. Just adding in more and more and more. I've got a little bit too far. We're at now 35,900. So I'll go down a level and add in a little bit more there. And we're getting pretty close there. And that's now sort of stabilized. So I'm at a figure there of, if we come back to the screen here, I've been adding, using that interface numbers, and I'm now at a figure of 35,980. Now, of interest, it's very much temperature dependent. So if I was now to bring my finger, which is reasonably, well, it is warm, down onto that Si5351 crystal, you will see the effect pretty straight away. So what I've tried to do, I've tried to bring the room up to my normal temperature. I've had all the equipment on here, including the SIGGEN on for well over an hour, just to bring things up to a nice, hopefully constant sort of normal user temperature. So in that particular setting, I'm now going to use that figure that we've come up with, so that 35,980, and we'll use that in our sketch. So if I was now just to swap over, I'll just close that window down there and swap across to the sketch I have been using for this particular radio, and we're going to go to the setup portion. So this is the setup function here, and we're now looking for the part that sends the various commands to set up the Si5351. Now I've seen sort of online a couple of different ways of using that calibration figure. For me, it didn't work putting it into this .init command, initialization command, as a third parameter. However, it did work by using it as a .set correction. So that's now 35,980, 35,980, and that's all you need to do. And as Simon suggests, using an indelible pen and then writing that number there, that 35980, onto the Si5351 board itself. So next time if I was to reuse that particular device in another radio, then I know that the calibration figure for that particular combination of Si5351 and crystal requires a calibration of 35980. And that's it. And as a consequence, if we now go to the very bottom of that sketch, I no longer have a need to apply, here it is down here, it's been commented out, that plus 50 hertz. That's now gone. So I'm now just going straight the BFO frequency minus our frequency of operation with no fiddle factor. And that's what I've been using. So if we now squirt that up, that should then pop up over here. I won't wait for that to happen. And suffice to say that by doing that, it's just uploading now, you can just see the lights blinking, that is enough to, like I say, negate the need for that fiddle factor. And as you heard before leading into this video, it certainly made the sound, I can disconnect that now, certainly made the sound considerably better. So hopefully that was useful. If it was a bit confusing, sing out and I'll try and explain it again. But suffice to say, I don't have a high accuracy frequency counter. As a consequence, I'm using the oscilloscope in the XY mode. If you wanted to, you could potentially use, like I did with the crystal filters, a HF receiver tuned to 10 megs, and then having the two frequencies will create, if they're slightly off, would be a beat frequency which you'll be able to hear. But like I say, I've got the scope there, so that's what I used. And obviously having a SIGGEN which has got the ability to go down to 1 Hertz. Rightio, well I'll leave it there, and we'll see what else is floating around tonight. And I will now sort of switch my thoughts into where to go next. It's been quite interesting. The only other change I've made to the radio is I redid the RF amplifier. So what I elected to do is just to make up just a general 3904 based amplifier using 10 milliamps and using the geometric mean out of the spec sheet. So the lowest was 100, the high was 300. So the geometric mean being 100 times 300 square root comes round to be, if I recall, 176. So I used an HFE, so a DC current gain of 176. Worked out the circuit and built it up. And what I elected to do this time, rather than having the amplifier running flat out with the emitter resistor bypassed, I took away the emitter resistor and just had it with the emitter fully in, just to reduce any possibility of this thing running away. And now it's rock solid, and doesn't matter how much variable capacitance or inductance has been provided back through to it, it doesn't break away in any kind of oscillations, both on 80 and 40 meters. Other than that, gain wise, it's not too bad. Overall we're trying to look for about 100 dB gain across the whole receiver. Those Plessy amplifiers there, they're providing about 17 dB gain. So all up, a lot of the gain we're getting in this radio is coming from the audio frequency amplifier. I understand, and something I've been thinking about doing, probably not for this radio but for a future one, is to have a modest amount of gain before the frequency selective component, or in this particular case, or in this case I should say the crystal filters, and have significantly more gain after that, which seems to be the better way of doing it from a noise point of view, I understand. So that's something I'm sort of thinking about. But for now, I'm sort of continue going with this because I just find it interesting having a playing around with these Plessy amplifiers. So just to recap, from a receiver point of view, not going to play around anymore with the RF amplifier. Pretty happy with the bandpass filter. That seems to be working okay. The mixers and the product detector seems to be working well too, which is great. And those Plessy amplifiers seem to be working quite well too, matched in with the 2 crystal filters. So, like I say, probably no more on this one. It could be considerably better, and I certainly acknowledge that. But at the end of the day, if you exclude the audio frequency amplifier, it's a pretty simple setup with 1, 2, 3 transistors for the RF components, and then obviously significantly more in the audio frequency amplifier there. Right, so I'm going to sort of turn my attention now to think about the transmit. Probably do voice first, SSB, and then start to think about the CW. So SSB, I won't talk about it now, but just start to put some thought into that. Anyway, 73s, hopefully that calibration procedure, like I say, wasn't too confusing. If it is, let me know and I'll try and explain it again. But otherwise, hopefully that was of use, and I certainly thank Simon for his input there, and others, and that will certainly be what I'll be doing from now on. I'll look to calibrate each board and do away with that fiddle factor, which was not going to be a linear option across the whole bandwidth of the radio. Rightio, 73s, and we'll see you next time. Okay, for those of you who decided to stay on after it finished, there you go. So that was that code I just squirted up there, 2 seconds ago. And that's really happy with that sounding. That sounds really good. Okay, 73s. See you next time.